During the first 12 hours of fasting, the body goes through several stages of fuel utilization. Initially, it uses the fuel that is readily available in the bloodstream from the last meal consumed, which could include proteins, fats, or carbohydrates. This stage typically lasts anywhere from 1 to 4 hours after starting the fast. Once the fuel from the last meal is depleted, the body starts recruiting stored carbohydrates, primarily from the liver, in the form of hepatic glycogen. The liver releases glucose from these glycogen stores, which is then used for energy by the body. After the liver glycogen is exhausted, the body enters a transitional phase where it begins to break down protein stores, possibly some muscle tissue, and small amounts of glycerol through a process called gluconeogenesis. This process converts these non-carbohydrate substances into glucose for fuel. Gluconeogenesis starts to increase around 4 hours into the fast as the body adjusts to the lack of incoming nutrients. Approximately 10 to 12 hours into the fast, the body shifts its primary fuel source to stored fat. The sympathetic nervous system initiates a stress response, triggering the adrenal glands to release hormones such as adrenaline, cortisol, and norepinephrine. These hormones, known as catecholamines, stimulate the fat cells to release triglycerides for energy production. However, triglycerides cannot be directly used as fuel. They must first be broken down into their components, glycerol and fatty acids. Enzymes such as adipose triglyceride lipase, hormone-sensitive lipase, and monoglycerol lipase work together to cleave off the fatty acids from the glycerol backbone. The fatty acids are then transported through the bloodstream by albumin to various cells for oxidation and energy production. Interestingly, the glycerol backbone of the triglyceride is water-soluble and can be converted into glucose by the liver through gluconeogenesis. This process helps maintain stable blood glucose levels and provides fuel for the brain during extended fasting periods. As the body becomes more adapted to using fat for fuel during fasting, it upregulates various pathways and enzymes involved in fat metabolism, such as PEEP-alpha, CD36, and carnitine palmitoyltransferase. This adaptation allows for more efficient utilization of fatty acids by the cells. In summary, during the first 12 hours of fasting, the body transitions from using readily available glucose to stored liver glycogen, then undergoes gluconeogenesis, and finally shifts to burning stored fat for energy. This process is regulated by hormones and involves the breakdown of triglycerides into fatty acids and glycerol, with the latter being converted into glucose for the brain. As the body becomes more fat adapted through consistent fasting, it becomes more efficient at utilizing fats for fuel.